Um, can everybody hear me? If I unmuted Dennis and
Yep, I can hear you.
okay.
Hear you.
Okay, just wanted to question because I can't hear. It's like I'm hearing myself talk. So we're going to talk today about spring fertility and soil testing. Just kind of some basics on, why do we soil test and what types of things we can do to, improve our knowledge on why we do it, and just to help farmers out to make some sense of a soil test instead of relying on everybody to give them recommendations and those types of things. So I'm going to get started here. Hopefully everything works out. So my dad, like probably 20 years ago, came up with the phrase test, don't guess. It was something that he wanted people to know, that the best way to know what you're doing is to test what you're doing. So you can get levels, you can see what your soil is like, what kind of nutrients you're missing, all that type of thing, to really improve your crop quality as well as production, and how to keep things healthy in your fields. And so we've done a lot of testing over the years. We primarily use Midwest laboratories, but we also use quite a few other labs as well. And I want to go through kind of some information that if you want to come to us to, do recommendations, or, to your local rep or whatever, kind of some of the information that might be needed for that. So I usually, like, when I talk to a farmer or I talk to a customer, I usually ask for like historical data. If they have anything historical, it really helps me to try to get some information on what's been happening previously. So just seeing what is going on now doesn't really give me any historical, like, well, what was last year's crop like? What was the year before crop? Have you been seeing decline? Have you been seeing improvement? A lot of those types of things are very important when we try to do soil analysis and, get that information. It's really helpful for me to try to get an idea. Now, if it's somebody that I've been working with for 15 years, and I have all that test data, then I can look back at that. But when I see somebody brand new come in the door, it's always good to have that helpful information. The other thing too is a lot of times I'll ask the farmer, well, what types of things have they observed? Has your soil been harder? Are you getting good water penetration in your soil? How has your crop been doing? So are your trees getting good blossom set? Are you getting good production? Is your wheat growing well? Are you getting a good stand, or is it stunted? Or, how's your production? Are you filling out the head? Like on soybeans, how many beans do you get per pod? Do you get 2s, 3s, 4s? Do you get any 5s? Do you get any 6s? That type of thing. So that kind of information really is helpful to get a picture of what might be going on at that point in the part of the springtime. So, so many people ask me a lot of times, well, what do I need all these different, testing for? And it's because a lot of times what we don't quite understand is a lot of information that we don't really get exposed to as much, as farmers don't get exposed to, is what do those nutrients do? So I put up a chart here that basically kind of gives you an idea of what different nutrients are involved in different systems on the plant. It's basically saying that there's a lot of nutrients that are involved. Now, there are some nutrients that aren't listed on there. My father used to talk about cobalt and nickel quite often, based upon nickel being a part of nitrogen metabolism. So, I mean, those types of things aren't as tested very often, but I do have some customers that do test for those. So, it's all dependent on what you want to do, how far you want to go, to just kind of look and see what you want to do for that. So there's a lot of information on this page. So we are recording this. So if you need some of this information later, just ask me and I can give you some of the information. So test requirements for accurate recommendations. So I see a lot of tests that come in that don't have a CEC, and typically, the lab is giving them full recommendations, so they don't think that they need to put a CEC on there. The CEC is important, and there's many different terms to do it. You see CEC, which is cation exchange capacity, EC, which is exchange capacity, but don't get that confused with, because electroconductivity is the same figure, so don't get those confused. And then TEC for total exchange capacity. So those are kind of the figures that you would get to get that information. What that information does for us is it gives us the information on, what your soil holding capacity is. And there's a thing called a CEC chart that gives us, from a 1 CEC all the way up to a 75 CEC, what nutrient requirements are for the potassium, the magnesium, and calcium levels should be in that soil type. So that gives us information on that. So other things that look really good for a soil test is pH. That kind of gives us a determination on, what our target range we want to be at. Organic matter or carbon to nitrogen ratio is important. It kind of gives us a guide of, microbial activity. If your carbon to nitrogen ratio is low, your microbial activity might be running low. If your organic matter numbers are low, microbial could be low. If it's exceptionally high, I've seen some organic matters at 15%. So basically, at that level, you're looking at, it's too high. You might not be getting proper digestion and not getting utilization of all the nutrients that are in that organic matter. So that's an important thing to look at. And then just the general nutrients, you look at phosphorus, potassium, magnesium, calcium, sodium, nitrogen, sulfur, zinc, manganese, iron, copper, and boron. Now, I put nitrogen on there, and a lot of times people don't run nitrogen because they don't think that's very important to look at, but it is if there's an excess. I ran into a customer quite a number of years ago that basically they were being supplied nutrients from their local fertilizer rep, and they didn't change, and he would take soil tests and he says, well, here's what you need every year. And it got to the point where nothing would grow, and he couldn't figure out, well, why am I putting on all this stuff but nothing's growing? So do I need to put on more? So he ran a soil test and he ran nitrogen on there, and his nitrogen level in his soil was over 500. So he was getting so much nitrogen that the crop would just come up and die, basically, because it had nothing else to support it, because they weren't recommending any traces, they weren't recommending any calcium. It was just NPK basically, and that was it. So that's important to look at as well. So if you have an excess or you don't have any existing, then we might need to do something microbially to get things going. And then a water extraction test. A water extraction test, I used to say that this is optional, but I like to see it nowadays because it's important to see what your nutrient levels are available. So basically, it tells us what is available to the plant at that moment, which is important to know, because most of the tests that we get are like a weak acid extraction or a strong acid extraction. So that isn't really plant available yet. So we need to learn whether or not we have nutrients available or not. So this is kind of an important thing to look at.
Mark, have you seen any sort of correlation or any connection between the idea of your normal CEC compared to the water extraction and microbial activity? When we start to increase the microbial activity and digestive capacity, do we see some of those water extraction numbers change?
Yes, usually they'll increase on available nutrients, and I do have some tests that I can refer back to that shows the correlation of before microbial application and after microbial application after a period of time of seeing the water extraction numbers go up.
Are there
So
are there any elements or any nutrients that you see usually go up more than others when we start to increase that activity level?
usually on that, you see the phosphorus, the potassium, you do see the calcium increase on there typically too. So, I mean, those are the three that you usually see more of the response um, on, making more things available. It's not, it's just a matter of it's all dependent on, what's being done, how proactive the farmer is, and those types of things on trying to get things moving. But it's a good initial test to have, and then, after that, to try to do this, see if what we're doing is working for them.
You
And
know,
it's Go ahead.
no, go ahead, Mark.
Go ahead, Dennis. That's fine.
One of the things you had mentioned about the excessive nitrogen from a chemical rep making recommendations, but didn't you see, wasn't there a grower that you saw that was putting excessive amounts of compost out? And I mean, how can that affect this also?
Well, the thing about it is excessive amount of compost too. It depends on how the compost is made. I see a lot of compost out of California that's excessively high in iron and also aluminum. And what happens with that is if you have those issues with having all that material in there, trying to figure out, what your nutrient numbers are that you're applying so you're not going to create an excess. I usually tell everybody to test their compost before they apply it, just to make sure we don't have some really bad accident. Or if somebody's applying a huge amount of manure every year, like 20 tons of manure or something like that every year, you're going to have some numbers that are really going to spread apart, and you're going to get some excesses and some depletions, just because if you overwhelm the soil with one certain nutrient, the others are going to either leach, or you're going to have, tie-up issues in there. And so you want to really try to, test everything that we're using. Typically, fertilizers are, required to have an analysis on them. And I've learned in the past to not necessarily 100% pay attention to that, because they might say NPK on there, but there's some other nutrients that they're not particularly required to show you. And so, because it's not in the typical ranges. So if they're trying to get rid of something, for instance, they can put it in that fertilizer as a filler to get rid of it. So I've seen that occur as well. So testing, your compost to kind of make sure you're not going to cause a major problem. If you're in California and you're doing, compost for your almond trees, and you dump on a whole lot of sodium, or you dump on a whole lot of iron or aluminum, you could potentially risk some disease issues. So you kind of really want to watch how you're doing, what you're testing for, what you're doing. And a lot of the guys that I work with in California now do test their compost, just to make sure they're not going to cause issues with their farms. So that's where it's important on that. So
Yeah, so we look at not only testing our soils, but testing our compost or our inputs also. That's really good information, Mark. Thanks.
yeah. So here's an example of a test. We use a lot of do a lot of work with Midwest Laboratories. It's only one of a whole lot of different labs, and there's a lot of information on tests, and usually the clearer they are, the better they are to read. If I'm a novice and I've never looked at a soil test before, this test would probably be an easy one to read. I've seen ones where they make me dizzy when I look at them. I mean, you have to try to sort through all the excess information on there that has nothing pertaining to what you're trying to do, that is not that important, but it just makes things so messy that they're hard to understand. So this is a nice, clean, analysis to look at. The other thing I want to tell people too is, when you're picking a lab, you don't necessarily have to look at what they recommend. I know a lot of different labs, do things as averages. So if your cation exchange capacity is 8.6, like on this test, and they look at all the nutrient levels, and you see potassium says very high at 165 for that cation exchange capacity, that's an average. They don't actually do it based upon, they calculate everything out by averages to determine on that, based upon that CEC, that's being very high. So it's not a true gauge of what the requirements for your soil or your plants are. So you have to kind of take it, and as you learn more information on how to read soil tests or what to really determine on a soil test that's important, it's something that helps you to, not necessarily take everything as, this is the way it has to be. So when you're looking at, like, Midwest Labs put base saturation percent down, I know a lot of guys will look at base saturation percents and go, hey, my calcium's pretty good, I don't need to apply any. Magnesium's okay, potassium's okay, and those types of things. So, you have to learn a little bit more about that. Like on this one here, it shows you got an organic matter at 7.1. They've never applied any microbial applications on that, so they're not getting any digestion of that organic matter. So those are types of things that you'll learn to determine on, maybe I need to do something to help break things down. And then, maybe I need to use less fertilizers if I can actually break stuff down that we already have. So it's important to look at tests and just kind of determine. So we're going to go through more stuff on the tests here in just a moment here. So when we used to do seminars, we used to have group gatherings of seminars, and we'd do multiple, we'd rent a hotel area, and we'd basically have the seminars. And I used to do a class just on figuring out how to calculate out your information for your soil test. So this here is kind of a sample page of what I would give everybody in the class to kind of go through and figure out the math. So we'd have a CEC chart attached. You'd take whatever the soil CEC was from your test, you put it on there, you'd figure out what the requirement was for, like, potassium, and then you'd do the math between them to determine on how much of a certain product I need to use on that soil. So you get your own information to learn on how to do the math and how to do the calculations and everything like that to really make it move forward. So, and I think that having some basic knowledge, you don't always have to do your own, but having the good basic knowledge of knowing how to do it is, information is power. You basically have power to know what you're doing on helping, seeing if somebody comes in and says you need, 500 pounds of potassium out there, and you calculate it out and you only need 250, what's going on there? Why are they recommending that much? Why do we need to figure out why we're recommending that much? So it kind of gives you a basis of being able to do your own system to know what information they're giving you. So, and those are available if people need them, just to try to learn some of the mathematics and stuff like that when you're doing calculations on figuring out that type of information. So, and we've all seen different types of tests. I wanted to put this up here, some of the different conversions to parts per million. We see so many times, you see an MEQ/100 grams for potassium or magnesium, and what does that mean? If you don't have the calculation information to figure out how to convert it to parts per million, a lot of times that information isn't very helpful to somebody that doesn't quite do the calculations every day. So I wanted to put this up here for anybody to look at, because I'm seeing more and more MEQ/liter now too, that gives you information. Now I put a sample of this up here, and if you look at calcium, for instance, on there, I don't know what the CEC is on this test. I don't know, it didn't have any of that information on the test, which kind of gives you less information to really know what's going on. But based upon their good level says, it's green at, greater than 3.6 is what they consider desirable. And you have 3.33, which is in the good level. But if you actually calculate that out based upon the, milli equivalents there down here with that, it shows a very small amount of calcium that is on there. So that, basically, in my opinion, might not be adequate amount of calcium in there. So we might have to look at why are they saying that's proper. If we had a CEC, we could figure out how many parts per million are actually required for that soil type, and then determine on whether or not that's accurate or not. So like I say, some labs, do it based upon their own philosophies, and what they think needs to be done. I've seen some labs where we've had recommendations for 3,000 pounds of calcium, whether or not you have a 1 CEC soil or a 35 CEC soil. So that can cause a major issue with, your other nutrients availability. So, we have to kind of look at what, information we're being given and what is the actual requirement. Because if you overwhelm the soil with calcium, your trace minerals are going to become less available. Your potassium, your phosphorus, all those are going to become less available if you overwhelm with one type of nutrient, basically. So you can cause your own imbalances by doing other recommendations that might not be as accurate as possible. So, and you look at, and then also down here at the bottom, I put milligram/kilogram, which is the same as parts per million. So if you see that, you can kind of determine that information as well. So this is a good sheet for anybody to take. If you want to take a snap of it or something like that, I would, that's great information to have. Just be careful, because I always try to tell people, you want to learn how to do everything, because sometimes you can create your own imbalances if you don't have enough information. So please, if you need to ask me questions or ask Dennis or Steve questions about the soil testing, feel free to, call our office or talk to anybody about, what types of things we can do to make sure that everybody's getting the right information. So on Midwest Labs here, we've got a sheet here, and it basically says pH, and we're going to go kind of over pHs and what the importance of pHs are, and trying to determine on, if you're too high, what kind of things you're going to have problems with. If you're too low, what kind of things you're going to have problems with. And it's important to know, what types of nutrients to put on. And it's also, you have to be careful, because a lot of times people will say, oh, you have a high pH, so we need to do a major corrective measures. I've seen people that have applied so much sulfur that their sulfur levels are up over 1,500 parts per million. So what does 1,500 parts per million of sulfur do in your soil? One, sulfur is kind of a drying agent, so you'd require more water. If you're limiting your trace mineral availability, those types of things. So you want to kind of be careful on what you do for, pH adjustments, because you don't want to get too extreme on trying to do things too much or add too much calcium of one type and then have 95% calcium and then all your other bases are all low. So we have to kind of, and a lot of times I've seen it where people have high pHs, and what are the other factors? So is their water high in pH? Do they just naturally, are they using fertilizers that are, extremely high pH or extremely low pH, and what are they doing? And also it kind of gives us a guide of what kind of nutrients we need to use to actually correct it over time. It's not going to happen overnight. A lot of times you don't see it going, quick, where you go from an 8 to a 7 in one season. That's very rare you see that. But it does happen. You can do changes over time. So here is a nutrient availability chart. Now this is saying that if the nutrients were available, they would be the most available at this pH. So at 7, which is neutral, which is considered ideal pH, those are the nutrients that are best available at those pHs. So as you get, I've been seeing trends of a lot higher pH soils. So in the 8s, the 8.5s, I've seen some in those ranges. And then I've seen quite a few lately as well that are in the 4.5 to 5 range. And I don't know why we're getting so many more with such a massive spread off of neutral. It could be what they're applying, whether or not be water or, nutrients or things like that. Because if they're not doing a lot of their own looking at the information and they're relying on everyone to do their recommendations for them, they won't know why their soil is excessively low on pH or really excessively high. So we have to that's why I'm trying to do this class here to kind of get people's awareness of what's going on so we don't end up with some massive spread at some point.
Mark, you talk a little bit about all the time. You've chatted with me about that, and a good thing to talk about here on the pH is what form or what are we using? You talked about sulfur to drop the pH, but a lot of times there's other thing where we're talking about lime or gyp or whatever we're doing, and by looking at our pH, it gives us indicators of what form of fertilizer we're going to use also.
Yeah. So if you're looking at, you need potassium, finding a potassium source that is a sulfate form, if you're, a high pH, might, help reduce some of the pH more locally where that potassium is being applied. Or calcium, for instance, on a lime type situation, calcium carbonate has a 7.2 pH. So if you're a low pH, and you need to bring it up, using a calcium carbonate would be a better form to bring it up. And barring everybody's information about gypsum being, a neutral pH, it's really not. It's actually a low pH. So you can actually do some shifts lower with a gyp, but it's also about availability of different things. Gyp is more available, immediately, but then it ties up and then it has to break down. Whereas you can play a lot of numbers on different nutrient and availability and things like that. So but this chart is based upon if everything is available, this is what would be available at those pHs. So that's important to look at, and also what kind of things you're picking for, sources of, nutrients to move your pH if you need to. But there's some things coming up too that are important to look at. So here's a chart that I got from Midwest Laboratories. It's actually from Dr. Cliff Snyder from Penn State University. And he basically figured out a chart based upon how much, if you're applying fertilizer and you're this soil pH, this is what you're going to be utilizing at that pH. So if you're running a lot of stuff and you're at a 4.5 pH, you're wasting about 71% of your fertilizer. So by applying, at that pH, because it's just not available. And as you go closer to neutral, if you see neutral pH, then everything is available at that neutral pH, basically. So it's a good chart to look at to kind of determine, wow, my pH is 6, so I'm losing about 20% of what I'm applying. So how can I, better that to get it? Now, like I say, pHs don't move quickly, so we have to try to determine that. And also, there's some things microbes can do around your root zone too that improve the pH locally so that the plant can actually get it. So necessarily moving your soil pH may not necessarily be as important with that factor involved. So looking at organic matter, so I got another test here with just an arrow pointing down organic matter. As you can see, it's quite a few different spreads on organic matter from 1.1 all the way up to 8.4. And you can also look at the CEC differences too. So if you go over the CEC on the 8.4 is actually 30 CEC, and the one that's the 1.1 is only a 5.7 CEC. So the higher organic matter level is, you're going to increase your CEC as well. So you'll better your soil over time. Organic matter is not actual carbon. So we don't want to say that organic matter is carbon. It's not carbon. You're not sequestering carbon. If the microbes break it down and get it more to the factor of carbon, then it will actually start returning into that point of, increasing your microbial activity, getting, higher carbon to nitrogen ratios, then increasing, a lot of different factors. Because if your soil biology goes up and your microbial populations go up, you're getting better nutrient availability. There's a lot of things that are involved in that. And just having, applying nutrients on your fields, if you have good organic matter, you have a lot of nutrient availability in there. And just something for anybody on that information. So if you had a 3% organic matter and you used 1% of that 3%, you'd be basically getting about 30 pounds of nitrogen. So out of that organic matter. So, applying nitrogen may not necessarily be necessary, because you figure if you have an 8.4 on the organic matter, you have a lot of available nutrients in that organic matter. All the data that has been done was based upon nitrogen, but there's also other nutrients in there as well. There's potassium, calcium. There's a lot of other nutrients available in organic matter. So, you can work on digesting some of that out so you're not so extreme, and work on getting a lot of nutrients that are more available to your plants right away, versus having to apply fertilizers and then kind of dealing with the difference in time frame of when they're going to be available.
Mark, when you start seeing that organic matter climb up to those higher and higher levels, what do you like to do? Is that cause for alarm? Does that mean something? What should we do if we start seeing our organic matter levels climb?
Well, typically, to a certain extent, it's good to have them climb. We don't want it really low, because then we're not giving anything back, and our soil's going to start to deplete on organic carbon over time. And so we're going to get our soils are going to get less and less productive as our organic matters drop. So if they're climbing, then that's a good beneficial thing. And I do like to see organic matter levels go up, but I usually don't like to see them go up any more than 4 typically, because then it means that we're probably not getting good digestion of that material. So our microbial populations are not as functional as they can be. There's been a lot of work in the past where we do microbial tests of the soil. You do anaerobic, aerobic plate counts and all that kind of stuff. And some people get these tests and go, wow, I've got a bunch of microbes out there, and so I'm doing really well. Not necessarily, because there's certain bacteria strains that are in the soil that will go massive populations, but they don't really necessarily do a lot of work for you. So that can be deceiving. So if you're seeing that and your organic matter level is climbing up above, tolerance where they should be, then, you might have to work on reassessing and reinoculating in there to kind of get those groups that are missing, to really help improve that digestion of that organic matter in there. And there are some negatives that can occur, and I've seen it a few times in fields, as well as Dennis saw it quite a lot in golf courses. But you can create a layer of organic matter that basically, it's called black layer. And what it is when the organic matter level doesn't get proper digestion, it starts to putrefy, and it can create so then you get the anaerobic bacteria that's digesting it instead and creating an alcohol base that then the roots don't like, and then you start burning off roots. So if you get too high, you can revert things to a negative and cause some issues. I've seen it in agricultural fields, a little bit, where they've had organic matter numbers up in the 6 range. So that's something to think about as well in the future, because they didn't have a lot. They were getting too much compaction, and it was starting to putrefy down at that compaction layer, and it was causing some negatives. So those are the types of things. You know, and then they also say visual residue on the surface is not organic matter. So it's not something where, you know, just because you have some stubble laying on the top of the surface, you know, it has to get broken down to a certain stage to be considered organic matter. I already talked about reserved essential nutrients in the organic matter. Also, if you have a higher organic matter, usually your soils are darker and better colors, so it looks like it's improving the soil quality. So those are things that are important there. So looking at the cation exchange capacity, you have a lot of variance and difference in that. So a higher CEC soil will hold more nutrients than a low CEC soil. So, and it kind of gives us a guide of, what to look for levels and that information. The other thing I want to stress to people, I've looked at a lot of fields in the past when people have gone to go buy a field. They send me an analysis. I look at that analysis and I tell them to please walk away, because the field is so depleted on nutrients that it would cost them so much money to rebuild the soil that it isn't worth the money that they're paying for it. So I had a case a number of years ago in California. They were looking at buying a chunk of ground, and it had excessive sodium. The iron was through the roof. The calcium was like 30%. The magnesium was 30%, and the potassium numbers was 0.5. So if you go and look at that and think, and the CEC was like a 25, I do believe. So at a 25 CEC, the amount of calcium to rebuild that would be in the probably 15,000 pound range. So if you think about that, that's a lot of cost to try to rebuild a soil. And it's not something that you can dump all that on at once and expect it to all happen immediately overnight. And so I've seen that where they've walked away, and then I've seen other times where they've bought the field already. And I told them, well, that'd be a great place to have your employees park, because it's not worth trying to rebuild, because it's, one of our customers down in California, he sent me an analysis after they had tried to plant trees in it twice, and the trees died both times because they couldn't get anything to survive in there. The ground was so poor that it just wouldn't support any life. So those are things we have to look out for on when you're looking at soil tests and CECs, to know that a higher CEC will take a lot more nutrients to recover, but it's also better for higher demand crops. So if you have a well-balanced higher CEC soil and you're planting in trees like a fruit tree or an almond tree or something like that, you're going to get a lot longer term support out of that soil than if you're trying to grow a high demand crop in a 3 CEC soil. You can get a 3 EC soil to do it. You're just going to be living out in the field trying to support it. So just think about those ranges on that too. So CEC and base saturation percent, this is kind of something here that, if you have a 3 CEC soil, your nutrient numbers are going to be low. That's where I was talking performance based upon, having availability of nutrients available, to support a higher demand crop. So you've got a thimble here versus a bucket. Steve gave me the analogy for visual people to do that. So if you think that you have a thimble full of nutrients and you're trying to support something, you're going to have to return a lot, over a short period of time. So it's going to be very demanding soil. You're going to probably have to have good foliar programs. You're going to have good return back on putting fertilizers down. and those types of things. And a 3 CEC soil is a very it's a very sandy soil at that point. So you really want to try to really support things at that. Whereas on a 20 CEC, if you fulfill that and keep those numbers up, you just have to maintain them. You don't have to go in and, you know, constantly exchange and put all the nutrients back every year, because you're not going to have the support for it. So that's kind of in those ranges on trying to just determine on, you know, how you're going to set up your programs and you know, what fertilization you're going to need to do and those types of things. So it's really important to pay attention to those. So cation exchange capacity, so it measures the soil's ability to hold nutrients. And, you know, it varies. I mean, I've seen CEC soils down to 0.5, and I've seen them all the way up to 70. So a 70 is like, it'd be great to make blocks out of. You know, you cut the clay out and you create it. You can create a nice building out of the 70 CEC soil, because it's, you know, almost pure clay. So you're going to have a nice building block. On a 0.5 CEC soil, you're going to be incredibly low on nutrient availability, holding capability, because it's so light. And if you put on too much nutrients on that, you're going to leach a lot of it. So you're going to have to kind of just watch your levels there. And looking at like a silty clay is going to be a higher quality soil. Silty clay loam will be a higher quality soil than a sandy loam soil. So, you know, just trying to determine that out. And then just, we already talked, a higher CEC soil basically holds more nutrients at that point. So some of the other soil health tools in here. So I put down some of the lab run tests that you can have done at a lab, you know, to really help you determine on what types of things are available, you know, for you to test for. Typically, you know, you want to run your soil test with your water extractable. I do have some groups that run carbon to nitrogen ratio as well, because the lab doesn't necessarily offer organic matter, but they do offer CNN ratios, which is important. And ideal CNN ratios is between 20:1 and 30:1. So that really makes your microbial populations go, you know, really well and function very good. If you're at a 10:1 carbon to nitrogen ratio, your biology is basically running at probably half its speed at that point. So that's a good determination on what, you know, to figure out if your biology is going to function in the environment that you're in. Because if your CNN ratios are low, you know, you're going to have to do a lot to help support those microbes to make them function as well as they should. There's so tissue and sap analysis testing, that kind of gives us a determination on how the plant is getting nutrition out of the soil, and maybe what we need to do to help support it beyond that. So whether or not it be foliars, or do we need to, you know, work on building our soil nutrients up, those types of things to really help determine that. The Haney test is just another type of nutrient test. It's basically considered a green tech test. So it's basically something that you can do, and it does require a lab to do it in most cases. So that's another test. Field run tests. So my dad, quite a number of years ago, back in the early 90s, was trying to find a way to give the farmer a way to do a quick test in a field to kind of get some information on how to test your plants out in the field and get just some general ideas on what kind of nutrient might be missing. So it was basically, you take leaves and you squeeze the leaves and you get the sap out of them, and you put it on a drop pH meter. It gives you a pH. Basically that gives you kind of, and then we have a pH chart that gives you a range of kind of whether or not you're, you know, above 6.4, which is what he considered ideal pH, and above 6.4 you were, you know, had certain nutrients you know, problems, and below 6.4 you had other nutrients, you know, problems. So, and it kind of determined on, give you some idea, because if you think about it, if you're low on like calcium, potassium, those types of things, you might be more likely to get a disease, for instance, or above 6.4, it might be an insect attack just because of the nutrients that might be in those pH ranges that might be just, causing problems. So then it kind of gave you an idea on, well, what nutrients are missing. But the thing about that test is you had to kind of make your own determination based upon what the levels were. And it's not a true, informational test where, you can get that and say, well, these are probably the nutrients I need to apply. And then if you worked in with bricks with it, it would kind of give you, well, it's not a potassium problem, it's a calcium problem. So those two worked very well together on, kind of giving you some field testing. Soil pentrometers basically tell you on how hard your soils are. There's some other tests like the slate test, the jar test, water infiltration test, and just a shovel test. So, you can kind of determine your soil density and, quality based upon doing the shovel test. If you want some information on like the slate test and the jar test and water infiltration, I've got some stuff that's really good from the NRCS. Basically, they're a PDF page on how to do those tests out in your field and work through those.
Yeah, Ray Archuleta in the Slake, he's got some good videos online as well. And I wanted to add in, there's the Graham Shepherd Visual Soil Assessment. That was originally designed Australia, New Zealand, where there's a lot of grazing paddocks, grazing land. And it's a way you can get out in the fields, and it takes a bit of time, takes a few tools, but you can evaluate your soil and actually get kind of a number associated with that mostly visual assessment. You're looking for worm counts, modeling, glaying, structure, how well it holds together. So that can be kind of a fun one. And then another one that I'm excited to start tinkering with and playing with more is microbiometer, and that's a PLFA test. So you're doing it in the fields. You get these little vials, and PLFA is phospholipid fatty acids. So you're using basically kind of different detergents, is I guess the way to kind of describe it, to take your soil and rip apart those bacteria and fungi that are in there, and it gives you kind of a score. It gives you a number to help assess how active those bacterial and fungal communities can be in your soil. So it's a fairly new technology, but it's one that I've been kind of keeping an eye on for the last little while, and I'm excited to give it a bit more testing and a bit more trial, because it could be a great way to help give, I'm not going to say a super detailed analysis, but it could be kind of like a speedometer in your car. It gives you a general gauge of how well that soil could potentially be performing. So that's kind of a fun one that I'm excited to play with more. And I think those tests are, $12, $15 per test. So it's something pretty easy that you do the analysis, and actually has a smartphone app. So your smartphone is helping you read the color change and color shifts of those little vials. So kind of a fun one. Just wanted to throw that out there. So that'll be a fun one to do some testing with here soon.
So Gary Redding had a question about the SAP pH that Dad did. Yes, I do have a chart that basically tells you what nutrients would be missing if it's high or low, and then what types of typically insects that are affected, or what type of diseases might be potentials, and how they increase based upon pH spread. So if you need that, Gary, I can get you a copy of that. We used to have it in our handbook all the time that we used to produce, but we haven't done a handbook in a while. So, so let's go here. So spring versus fall applications, there's certain nutrients that we typically can apply in the spring and others that we apply in the fall. Some of them have to break down to a certain point when you apply it. So we go through and typically, I've heard a lot of farmers are getting anhydrous put out, in the fall. And I'm thinking, oh, that is interesting, because anhydrous is not, you're going to lose a lot of it over winter. So seeing that they're applying nitrogen in fall to winter over is probably not the best application to do in the fall. So that's just something, because you don't want bunch of your material leaching and losing a lot of your dollars that you're putting out there to try to put these nutrients down. So certain nutrients are, like you got nitrogen for spring application, phosphorus, boron. Those are the ones that primarily leach or tie up quickly usually. You can apply, calcium. You can apply a lot of these other ones. Just don't and you can do copper, you can do iron, manganese, sulfur, potassium and stuff during the spring on soil. It's just, you may not see a response as quick as you'd like to see. So, copper, and then I am always a big proponent of foliars. So, getting your soil functioning well may take a period of time. We typically say it's not, an instant overnight thing where we can do it in one season. It typically takes a couple of years to get things really flowing and functioning well. So getting all those nutrients in there and getting it all broken down to where it's available to your crops, getting the microbial populations working well, doing all that type of stuff. But in the meantime, you have a crop. What do you got to do? Well, foliars are a great way to get it there. So, if you have to put out spring applications of calcium to pick up, that information, and a lot of nutrients too. So typically calcium is lowest in the spring and it builds. So you're kind of looking at what kind of nutrients you need to apply, at what timing to, really build up, that information. So here is an actual chart that's been developed. It was a lot of work with my dad, Bruce, and also kind of me working with all the data for so long. I have, thousands upon thousands of soil tissue tests that I've looked over and done a lot of calculation for. So if you look at this chart, this kind of gives you a guide of a rough range of where the nutrients should be in the tissue. So it kind of gives you a good correlation of how our plants are taking out of our soils and what we really need to do to build our soils up so that we can get a better support, because foliars are good. And with the sap analysis now, you can get a little bigger window picture of knowing of what your nutrient levels should be a bit earlier, so that you might need to apply something to get a better shot at it. Tissue sampling, you can get that window. It's just a narrower window. So learning, this is based on plant nutrient analysis. So it's just learning to know what our plants are telling us early on and what kind of nutrients we need to apply early on, and getting everything going so that we can get a full functional system going.
Yeah, and Mark, that this was designed and based off of a plant tissue analysis, so it doesn't really correlate to a leaf extract or a plant sap analysis.
No,
yeah,
it does
I just
not.
wanted to make sure. Yeah.
Yeah. So nutrient applications. So I just basically talked through a little bit of it. Calcium is normally low in the start of the growing season. And I've seen numbers, in calcium's really incredibly low in the spring. And then by mid-season, you're at a 4% on a tissue analysis. On a sap analysis, the numbers will be different. But a lot of the data that I've scanned over the years has been tissue analysis, because sap analysis is quite new. But it is, gaining in popularity, as well as, the information it gives you, they're getting more time, and getting more data as time goes on. So they're getting more information. So that's basically on the calcium there. And then potassium in the spring, it usually I've looked at enough test data to know that it increases up. And then once the crop is set, usually you'll see it start to drop because it's being utilized by whatever it's filling. So, that's where it goes there. And spring tissue tests are, a good thing to take, whether or not it be sap analysis or tissue analysis, to kind of give you, to look and see what we're going. But some crops, it's good to see a test from the fall, because if you're having difficulties in the fall, you'll know beforehand, because things like almond trees, for instance, you can't apply anything really because there's no leaves initially. You basically get blossoms and then the leaves come out later. So it's something that you have to kind of pre-plan for, to make sure that you're looking at it closely enough to get things going. If your soil's functioning well, then you're getting good nutrient support through the root system, as well as if you're doing some late season foliars from last year to kind of store stuff up as well, then you're going to be better prepared for spring. So on those types of crops. So there's a lot of different information that we can learn from, what we're seeing in there. So biology. So basically biology is something that's really, I think that's the key to the system. I mean, if we don't have it, we're not going to get the nutrients we need. If you think about the nitrogen cycle, breaking down phosphorus, breaking down calcium, all that stuff, you get some breakdown through degradation in the soil of just water flushing through and creating that breakdown. But primarily everything is based upon microbial breakdown. In the past, there was a lot of things where, we were out to kill anything bacteria, it's all bad. And now the programs have changed so much over time. Now a good successful program has some type of, microbial system that they're using of some type to be successful. So that's where the change has been done. And I do believe it's a very, very good change for the future here. So role of biology in plants. I mean, you look at increasing nutrient availability. You can break down your stubble. You can get better organic matter availability. We can do sodium reductions, increasing soil structure, and water penetration, helps as well, and getting better, so your water just doesn't sit up on top and then it evaporates, or if your soil, if you have a lot of less organic material and not as much biology, creating a lot of the different type of soil glues that help retain stuff, the water could flush right through your soil. So there's a lot of stuff involved in that. Reducing compaction. It's very important, because compaction can, if your soil isn't functioning well, you're not going to break up those hard pans. Stimulate a lot of root growth. So as you're getting your roots inoculated with the biology, they're feeding the roots are growing, the biology is moving along with the root system and expanding as the roots are growing, and then they're getting a lot better nutrient availability. And also changing the pH around the rhizosphere. So there's been data that's been done in the past here now that's just, a lot of work has been going on. And it's basically showing that the pH shifts. The biology doesn't like extreme pHs. So the biology will shift the pH to more of a beneficial pH for their function around the root system. So even though your soil may be an 8 pH, and you're panicking and trying to figure out how to reduce your pH down to neutral, the biology, if you have good biology support around that root system and good food for them, they've already shifted it to their need. So that's a functional thing to make it, because their enzymes are less effective in a different, a higher soil pH or a low soil pH. So they shift it more toward where they need it for ideal purposes. So you hear a lot about our products. Here's quite a few of our different ones that we typically recommend for spring applications. We got the Spectrum Plus Micro, Spectrum PSB, and Spectrum DS. And then some of our liquid products that we typically recommend are like the Nutrineed, the Pepsime Clear, and the Pepsime G. these are good products to go out and inoculate your soils in the spring, as well as, you know, stimulate your biology, stimulate new root growth, and just general, you know, biology stimulation. So we're trying to get the system working and getting that soil digestive system functioning well.
You know, Mark, and a little bit of talk about here, another information that soil analysis give us, not only the nutrient deficiencies and or excess, but a lot of times based on a biological inoculum, we make a recommendation based on that information that we receive from that soil analysis. So, you know, a lot of times if we see a soil which is at high sodium, then immediately we realize, well, we've got some stress going on in that plant. We have high sodium levels, so we want to use the Spectrum DS, which is designed specifically to help reduce that stress on the plant. Same thing when we look at phos availability. If we have high phosphorus but water extractable, we're not seeing phosphorus available within that plant, or the plant's not getting it based off a tissue analysis or a leaf extract or plant sap analysis, then a lot of times we look at going, well, we might need some of those phosphate solubilizers, or just maybe the regular Spectrum product is designed just for a good balanced inoculum for those soil environments. So a lot of times that soil analysis gives us more than just fertilizer recommendations. It also helps us with how to feed our inoculums, how to support our biology within our soil environment. So there's a lot of good information that's utilized. A lot of times I tell people, don't be reactive when they see that, be proactive. What things do we need to do to fix our soils?
Yeah. So yeah, that information, soil tests are very, very important to have. And I do see a lot of times too, where people have sent me tests that are 5, 6 years old. And I usually say, well, that's good, you know, historical data, but we do need something closer up. Especially if the CEC is low, you know, it's not even going to be close to accurate. So basically we just need to, you know, determine on what kind of things that we need to do for that soil. So, and then I put down my dad used to love this Franklin Roosevelt saying. It says, a nation that destroys its soils destroys itself. So, and if we have any questions, now would be a good time to ask questions. So I got a question from Jerry. It says, what is the first item I should look at on my soil test? So looking at a soil test, so let me see if I can go back to one here. So usually my first thing when I see a soil test, I look at the base saturation percent first, just to kind of look at pH, base saturation, to see, you know, that's something that as anybody can just visually see. You know, ideally, my dad liked to see, and we typically recommend, you know, potassium between 6 and 7.5, magnesium about 12 to 15%, calcium about 65 to 75% typically. So that kind of gives you an idea of where to look for your numbers to be at. And then the soil pH, determining on, well, if I need to apply something, you know, what can I do for, you know, what type of nutrients should I apply based upon my soil pH? Because you don't want to create extreme problems back and forth. I also look at organic matter to see whether or not, you know, you've got a high organic matter. Do we need to do more microbial applications? And if you have the water extraction, then it kind of really gives us a guide whether or not you have anything truly available. And then, you know, microbial applications as well. So, I mean, it's just looking at it as a whole, but, you know, kind of picking out certain aspects of it is something good to look at. So, I mean, that's something, hopefully I answered your question on that.
You know, Mark, one of the things that I look at also on the soil analysis when I go through there, kind of in addition to what you looked at, is I look at the deficiencies and the excesses. Generally, I am not as concerned of the deficiencies because we can make those corrections. but I look at the excesses and I look at excess. How is that reducing the availability of something else? Because once we have an excess in our soil, we can't take it away. So we have to manage it.
Yeah.
So a lot of times that gives me the information of, I have an excess here. What else is that tying up and making not available that I won't be able to get into that plant? And how do I fix it? Which, you know, is very, very important.
Yeah, if you have like an excess sodium level, I've seen some really pretty high ones. I've seen sodium levels up into the 2,000 part per million range before. So I mean, if you have an excessive sodium issue, if your calcium, I've seen calcium up in the 92% range. There was some programs that were going on back east that they were just saying just apply calcium, because that's one of the most important nutrients that you need to apply. Well, they got actually too much calcium. So then you have to see, well, what do we need to go, to reverse that kind of flow? If your iron is super high in the soil, that can be also another negative, because iron can cause, if the plant takes it up because it has maybe some deficiencies, iron is usually pretty easy for the plant to receive. So it'll take that up thinking and substitute certain nutrients for it. And then it'll get into the vascular system and cause, plugging up of the vascular system, and it can't get rid of the iron. So it doesn't know what quite to do with it. So, and then it sets itself up for potential disease issues because it has excessive iron built up in there. So, I mean, looking at excesses is important to really determine on, what our soils are going to function. And so there's a lot of different issues with seeing the excesses or the really bad deficiencies as well. If you have non-detectable on some things, and you've got some serious issues. Usually you don't see too many non-detects, but you can get them down to where they're like 0.1, and it gets pretty bad for trying to rebuild things up.
Yeah, another thing I like to say on the soil analysis, I mean, this is probably going a little bit beyond what the question was, but I always caution people that when recommendations are given to where our deficiencies are, we don't need to try and fix that in 1 year, because then generally we throw other things out of balance. So, Mark, you had mentioned it's a 2 or 3 year program. I mean, if you're deficient on calcium, let's not go out there and throw 2,000 pounds of calcium or GIP out there all at one time. If that's what our deficiency is, let's do it over a period of time. Let's do spring and fall applications and slowly bring that back into balance. Again, we didn't get there in 1 year. Let's not try and fix it, because, Mark, Bruce used to talk about yo-yoing the nutrition. We fix one thing and we throw something else out of balance.
Yeah. And typically when I give recommendations too, if I see an extreme amount of nutrients that are required, if you're like in this area, if you're a wheat farmer and you haven't applied calcium for a long period of time, I've had one group that was, and he was so deficient on calcium, their family never applied any calcium on their farm as long as he had known it. And I mean, he was super deficient, and his yield was incredibly small. So we worked out a program for him over about a 7 to 10 year period to build it up so that he could afford to do it. So that's something where we can work on programs to extend it out. Plus, I don't want to have somebody apply huge volumes of calciums all at once, because then you're just going to create another imbalance. So we have to try to work through the programs in that. And so if you see recommendations where they're recommending 6,000-7,000 pounds of calcium, break it up over a 5 to 7 year period, or even longer, depending on budget and those types of things. So we're not actually going to overdo it. And the plants will respond to when you're applying calcium, even if it's a smaller amount, because some of that calcium is available right away. So you'll see the response, but you're building up your capacity for long term. So that's where we try to, develop the programs around that. I have a question here. It says, which labs have the best biology reports? I'm kind of torn on doing biology testing of soils. I mean, you can run, plate counts. You can do some individuals. They usually get pretty costly though, to do that. I think that if you want to run a baseline, like doing a anaerobic aerobic plate count or something like that, or they have some other testing just to determine on levels, but those can be deceiving. And that's where, if you see the tests, and you say, wow, I've got lots of biology, but why am I not getting good production? Then there might be, like I say, the gaps in the nutritional that you can't see. So I typically don't recommend anaerobic aerobic plate counts anymore unless you're having some severe issues. And I've run them before on areas that have been contaminated with like herbicides and things like that, just to kind of see if they have any biology functioning there, and what we need to do for that application. But typically I don't really recommend, doing that. And then I have another question from Faith. She asks, how do you feel about the Haney test? I don't have a lot of experience with the Haney test. Steve, do you have any more?
I can answer a little bit on that, Mark. The Haney test, I mean, it's a great test. It gives you an overall test health score based on 0 to 50. I mean, it looks at CO2 respiration, water extractable carbon. It looks at water extractable nitrogen. And then they also, part of that score is, I think they call it the H3A soil extract, which is a way to design or mimic organic acids within the soil. And, it's a great test. It gives you a snapshot of what is going on within your soil environment at a given period of time. Some of the things that I guess I am concerned with about it is the way they do that test, for example, on the CO2 respiration, is they take that soil that you send into them, they dry that soil out, and then they re-wet that soil, and over a 24-hour period of time, they see what the CO2 respiration is. So it gives us an indicator of overall soil health, but we don't know, as we all understand, when we excessively dry out our soils, we lose some populations within that soil environment. So who comes back and responds on that respiration? So it's a good test. It gives us a picture. The thing I like about it is it lets us know, when I look at it, is what do we have in water extractable carbon, and how well are the microbial community going to survive within that soil environment? What are we seeing on the water extractable nitrogen, which is a food source for the microbial community, and to help make immediately available nitrogen to that plant, and also helps with the breakdown of organic material within that plant, because obviously they need that nitrogen to break that carbon chain. So it gets that process going. So it gives us some information, but it doesn't give us any indication of who are the players on the field at any given time. It just kind of gives us a broad picture of, yeah, we got some CO2 respiration, but we don't know who's there. Some of the things I look at is DNA sequencing. That's becoming available now, which can give us, again, a snapshot picture and breaks our microbial community within that soil environment into groups. It lets us know our nitrogen fixers, our phosphate solubilizers. So it kind of gives us groups of the microbial community within our soil environment, but it still doesn't break them down individually. And Steve, you were talking about the test that you're really excited about.
Yeah, so there's the microbiometer, and the question about Haney and the question about microbial activity testing. Those two definitely go together, because as far as what's on the market available today, Earth Fort does some testing, Ward with the Haney analysis. those are some of the more biologically friendly. The microbiometer is fun and exciting. I'm excited to see PLFA come to the masses and make it more accessible for more people to use. There's another one I've been talking to, some Biomaker, and they're kind of doing what you were talking about, Dennis, where they're using PCR, polymerase chain reaction, and DNA, basically chopping apart the DNA and looking for those different activity profiles, so we can get kind of a snapshot of, okay, I pull my soil, and again, not perfect, it has to be shipped, it has to be processed, so we're going to lose some guys there, but we get a general idea of, oh, we're looking for nitrogenase activity. So we look for these different enzyme or protein activity groups that are going to give us a general indicator. Again, kind of like what I mentioned, it's not precise. It's kind of like the speedometer in your car, but with a big wide range. So it gives you a general indication of what's going on down there. So it gives us something to go with. And I'm excited to see over the next several years, because with the increase in popularity and understanding the importance of soil biology and the digestive system of the plant being based around that microbiome, there are more and more companies coming online with more and more advanced tools. So I think that right now, I mean, 5-10 years ago, yeah, there's the Draeger tube, which is looking at CO2, the Solvita, and those are great tools, but I think that on the horizon, we're going to have access to much better technology. Some of those companies are coming along because people, again, are realizing just how critical the plant secondary biome is. Its microbiome is absolutely critical for gene expression, for function, for nutrient uptake, and protecting itself. Those microaggregates that are formed around that root zone that create that interface between plant and soil, we're starting to see just how critical those truly can be. And so there are more and more labs. So I'm excited over the next, I'm going to say 5 years on where we're going to be. And I mean, ask that question again in 5 years, and I bet there will be much more precise answers. So yeah, the microbiometer is fun to watch. I'm watching Biomaker. There are a few others that are doing somewhat similar technologies of doing exactly that, ripping apart who's there and then trying to put it back together into groups. So yeah, it's a fun time to be watching some of these things.
So we got another question. It says, can you talk about the role of cobalt, molybdenum, selenium, and silicone on plant health? So molybdenum is basically something that is explainable, and they talk about it in a lot of the available things here, like in enzyme regulation. It's involved in carbohydrate metabolism, nitrogen metabolism, those types of things that it's all a part of. Selenium is a required nutrient for animal health. So if you're doing sheep or you're doing cattle or things like that, that's very important for that. I don't know, do you guys know if there's anything related to plant health that's selenium is involved in? Dennis, Steve?
Yeah,
Go ahead, Steve.
it's an area that we have some research. There isn't a massive amount of research. The B vitamins and sometimes the oxidative pathways, so protecting the plants against stress. A lot of times, some of those higher end or lower ends, I guess lower quantity trace minerals can be pretty critical in there. Vanadium isn't mentioned, but again, that one can go into our nitrogen pathways. Mark, you already mentioned the molybdenum. Silicone, we're finding more and more research coming out on silicone. It has a number of functions in the plant. What people are most excited about right now is what it's doing mostly for anti-herbivory, for protection. And what we're finding is amorphous silicon is being deposited in the plant's actual physical structure. So in those cell walls, in those cell structures. So it's creating a more rigid plant, a better protected plant. And this has been monitored in wheat for quite a while. And knowing that as our silicone levels go up in the wheat plant, it is a better protected plant, has better cell structure, has better flex. Like we talk about the calcium pectate, we're seeing silicon do a fairly similar thing in creating a more rigid structure for that plants. And that was in wheat, and now we're starting to find it more and more in a wide variety of plants, seeing pretty similar benefits where we're seeing a lot of it is focused around that plant's being able to protect itself, its physical structure. And as far as selenium, yeah, I mean, this core metal ions, I'll have to look up some of the enzymes specifically. I know it can be involved in oxidative stress and reduction. So yeah, that's one that I'll have to do a little more research on.
So hopefully, Lori, we got your question answered. Cobalt was a nitrogen metabolism benefit. So was nickel. Those usually are some really minor trace elements that are involved in that as well.
And also photosynthesis.
And photosynthesis. Thank you, Dennis. So do we have any more questions? We've ran pretty long here today. We've done like an hour and a half. But I wanted to thank everybody for coming. It's been a great talking to everybody, and I hope to see you on the next webinar. Thank you, everyone, for coming.
Thanks,
Thanks, Mark.